Hello, my dear students. Welcome back. So today we are going to start a new chapter, that is Science chapter 13, Motion and Time. Okay, and this chapter, if you remember, in the last class I have given you a brief introduction, right? Now regarding the linear motion, the circular motion, the periodic motion, and all this linear motion, all these motions you have studied in the class 6. Okay, so now today we'll discuss about uniform motion and non-uniform motion. Okay, first let's discuss about uniform motion. Okay, uniform motion. Okay, now let's consider this guy. Okay, this guy as one of you. Okay, now he starts. This is the initial position. Let's mark it as A. Okay, A. So now he wants to go to this position D. Okay, D. Now clear. A, B, C, D. Clear. Now from A till B he takes 1 minute. Clear. From B till C he takes 1 minute. Clear. Now and from C till D he takes another 1 minute. Clear. Now in all this AB he is covering 1 kilometer, 1 kilometer, 1 kilometer. Clear. Then see, students, he is covering equal distance in equal interval of time, right? In every 1 minute, this guy is covering 1 kilometer, right? In 1 minute, 1 kilometer. Another 1 minute, 1 kilometer. Another 1 minute, 1 kilometer. So this is an example of uniform motion, okay? So if a body covers equal distance in equal interval of time, then it is called uniform motion, okay? So I'm sure you are clear with that. So the second, let's discuss about the non-uniform motion, okay? Non-uniform motion. But students, it is impossible, okay? It is impossible to be in uniform motion, right? You cannot expect yourself, okay? Suppose this is your home, okay? And this is your school, clear? You cannot expect like to travel in a same like distance, you cannot expect yourself to cover same distance in same time, right? Because sometimes you might walk a little faster, sometimes a little slower, right? So in real life, only this one is possible. There is non-uniform motion, okay? So like now let's say this guy, okay? The same guy from point A till B, till C, till D. Clear? Now let's say these are all 1 minute, 1 minute, 1 minute. Clear? Now here he took 1 minute. He covered 1 kilometer. Let's say he covered 1 kilometer here, okay? And here he covered only half kilometer. Clear? And here he took another 1 kilometer. Right? That means, see, this guy here, if we check the distance and the time, it is not equal, right? So this is an example of non-uniform motion. Clear? Now, if a body cover unequal distance, okay, unequal distance in equal interval of time. Now time is equal, see. In every block we have 1 minute, 1 minute, 1 minute, but the distance that this guy cover to reach the final position D is not equal. Clear? So this can be an example of non-uniform motion. Clear? Now see, even for any car, we cannot expect okay, let's say if you go to your school, okay, by bus, school bus, you cannot expect your school bus to cover equal distance in equal interval of time, right? Sometimes the driver might slow down, sometimes the driver might increase the speed, right? Sometimes on your way to school, there will be a traffic, right? So in a real life, only this one is possible, okay? Non-uniform motion, okay? Okay, so we are done with the uniform motion and non-uniform motion. Now, let's discuss about the speed, okay, speed. Okay, so students, for speed, it is distance by time, okay, very simple distance by time. That is the formula and that is the definition. But let me tell you that since in real life, okay, so if you want to calculate the speed of the bus, okay, from your home, from your house till the school, then we have to calculate the average speed. Average speed. Clear? Since we are not covering equal distance in equal interval of time. Clear? Because in 1 minute we are covering 1 kilometer, in another 1 minute we are covering only half kilometer. So we have to take the total distance covered. Okay? So for speed, the formula would be total distance covered by total time taken. So this is the formula, and in simple word you can write speed is equal to distance by time. So this is the formula, keep in mind. Okay. Now students, see, let's say this is number 1. This is the first formula to calculate the speed. Okay. Now, the definition is very easy. Speed is defined as the total distance covered by time. Clear? So, this is the first formula. Now, if you are told to calculate the distance, so from this formula itself, if you are clear with this formula, then we can calculate distance and time as well. Okay. So, for second formula, just from here we will write a new formula for distance. Okay, so for distance, students, look here. See, distance means you can take cross multiplication between speed and time. Okay, speed into time. So this is the second formula for distance. See, distance is equal to, you can just take cross multiplication between the speed and the time. Clear? Now, the third formula I will write over here, okay? The third formula would be for the speed. I'm sorry, that the third formula would be for the time, okay? For the time. Okay, let's write time here. So this is the third formula, okay? If you get a question to calculate the time, then what you can do is, students, see, since you want to calculate the time, right? You want to calculate the time, so what you can do is, this one will go here, okay? This one will go here, so it will be distance by speed, okay? Distance by speed. Time is equal to distance by speed. So just if you are clear with the speed formula, you can get any formula from here, okay? Either you'll be able to get the formula for distance as well as for time. So I'm sure you are clear with the 3 formula. So you can note down all this formula. We'll start another topic. Clear? Okay, so students, now we are going to discuss about the units, okay? Unit. Now, the basic unit of distance, okay? The basic unit of distance would be meter, right? M-E-T-R-E, which you can just write M. Clear? Now, what about the larger unit, okay? The larger unit of distance would be kilometer, right? Kilometer. Clear? Kilometer. Okay, now about the time. The basic unit of time would be seconds, okay, which you can just write, okay, seconds. Now, in the larger context, it is minutes, or you can also write hour, right? But the basic unit would be seconds. Clear? Okay. So students, I have already explained regarding the formula for speed, that is distance by time. Right. So from here, what is the unit of distance, students? The unit of distance is meter, right? The basic one, okay, meter. Now what is the unit of time? It is, the basic unit would be seconds, right? So whenever we do calculation, okay, for the speed, the unit should be meter per second, okay? You can show in this way or in this way, okay? So both this one and two are right, it's the same thing, okay? So for the unit of speed is meter per second, okay? The basic, the one that which I wrote here is the basic unit, okay? Basic unit for speed would be meter per second, okay? Now, on the larger scale, we can also write kilometer per hour, right? Kilometer per seconds, the larger one will be hour, right? Or meter per hour as well. Clear? So this we are discussing about the units, because in a numerical, if you don't write the units, you will not get full marks. Clear? Because if it is speed, we have to show the unit. If it's distance, we have to show the units. Clear? Okay, so I'm sure you are clear with the formula that we have discussed. So based on the formula that we have discussed, let's solve numerical, okay? So in your textbook, you can turn to page 156, okay? 156, the question number 4, okay? 156, question number 4. Let's calculate this numerical together. Clear? So students, page 156, question number 4. Clear? So the question goes like this. The distance between two stations is 240 kilometers. Clear? So answer, the distance is already given, right? The distance between two stations is 240 kilometers. So we'll write given, okay? Given distance is equal to 240 kilometers. Okay, now the next part of question says, a train takes 4 hours to cover this distance. 4 hours, that means they have already given the time. Clear? They have already given the time, that is 4 hours. Okay, or you can just write in the units, HR. So distance is given, time is given. Now they are asking, like, calculate the speed of the train. So we just have to find the speed. Clear? Now let's recollect the formula that we have discussed just now. That is, speed is equal to distance by time, right? This was what we have discussed just now. Now, in this question, we have to calculate the speed. Distance is already given, time is already given, okay? So distance, it is 240 kilometers. Clear? And time, it is 4 hours. Okay, 4 hours. So 4, if we divide this one 240 by 4, we get 460, right? So that means the answer we are getting, that is 60, and what is left? We have the unit, that is kilometer per hour, okay? Kilometer per hour. So the answer we are getting for number 4 is 60 kilometer per hour, okay? 60 kilometer per hour. So you can write this, the speed of the train is 60 kilometer per hour. It's very simple if you know the formula. Clear? So we are done with the first numerical. So in science, the numericals are quite simple if you know the formula. Clear? Okay, so now we are done with the 4. Now everyone, let's do another numerical. Clear? So question number 6. Question number 6. Okay, that is Salma takes 15 minutes from her house to reach her school on a bicycle. Okay, so that means the time is already given. Question number 6, okay, the same page 156. So answer, okay. Now given. So time, it's given 15 minutes. Clear? Now, if the bicycle has a speed of 2 meters per second, now the speed is also given. That is 2 meters per second. Okay. Now see, m means meter. Okay. S means seconds. Don't get confused. Because speed, like I've already explained, speed means meter per second. Clear? Okay. Now what do we have to calculate? Now the question says, calculate the distance between her house and the school. That means we have to find the distance. Distance is what we have to find. Clear? But students, I have already explained that the basic unit of speed is meter per second. Okay? And the time here they have given in minutes. So before we apply the formula, you have to convert this 15 minutes into seconds. Okay? So what you have to do is you have to multiply this one into 60. Okay? See. 15 into 60. Okay, so now we have already converted this one into seconds. Okay, so we are done with the conversion. Now let's solve this numerical together. Okay, so if you get confused, what you can do is you can just apply the same formula, that is speed is equal to distance by time. Then since we have to calculate the distance, you can write distance is equal to speed into time. Okay, in this way as well you can solve. I'm just showing you different ways to solve the numerical. Clear? Okay, so I'll continue here. Okay, now students, now the speed is 15 into 60, right? Seconds. Now, the time, okay, this is the time, okay, 15 into 60, and the speed is 2 meters per second. Clear? The speed is 2 meters per second. So, clear? So we just have to multiply. Now, if you multiply all this together, which you can also do along with me in the rough work, okay? You will get, okay, you will get 1800, okay? 1800 meter. Clear? Because we have converted this time into seconds. Clear? Since we have converted this time into seconds, that's why we are getting 1800 meter here. So this is a very simple way to solve the numerical by applying the basic formula. Okay, so I'm repeating again, but whenever you solve the numerical, first you have to list down the ingredients, okay, like whatever they have mentioned in the question, okay, whatever they have mentioned in the question, you have to write it down. And then the second thing what you have to do is you have to apply the formula and see, okay. So for calculation related with speed, distance and time, what you can do is you can just write this formula, and from here whatever the question they're asking, you can do the cross multiplication and you can get the answer. Clear? So this is about the question number 6. So in the next class, students, we will continue with the periodic motion. Okay, periodic motion, and periodic motion is also known as oscillatory motion. Okay, keep this in mind. Periodic motion is also known as oscillatory motion, and a very simple example is a pendulum, a simple pendulum. Okay, now a pendulum looks like this. Okay, so we will continue this one in the next class, but just to get familiar, okay, to get familiar with the topics that we'll be discussing in the coming class, I'm just drawing this one for you. Okay, so this is a simple pendulum, and this is an example of a periodic or oscillatory motion. Clear? So thank you so much, students. That comes to the end of this class. See you in the next class.